everybody. Today I'm going to talk to you on how to read these type of graphs. A lot of you were curious on how to do this and struggled on your previous exam, so I thought it would be good to explain it in a short video. So to start, I want you to feel familiar with this plot. I think you guys have seen it multiple times, and Dr. Babs has showed you this as well. So we're going to start with labeling the x-axis. So the x-axis tells us the amino acids from 0 to maybe approximately 700 for this particular hormone receptor. On the y-axis, it tells you how hydrophilic it is and how hydrophobic. So I'm going to use my pointer spotlight. There it is. Here, anything below 0 is going to be hydrophilic, so it's going to love water. When it's hydrophobic, that means it does not like water, so it's up above here, and that can be found within the membrane, hence why we see transmembrane, or we call it transmembrane. So another thing to take into account is that there's a lot of lines on here, and not each one represents a transmembrane domain. Only a line that's going to be wide enough, about 20 to 25 amino acids roughly, is going to be a transmembrane domain as seen here. So this human growth hormone receptor only has one transmembrane domain. Do not confuse this label of a signal sequence as a transmembrane domain. You have to consider that there has to be 20 to 25 roughly amino acids. So in this case, you're looking at about maybe 270 to 290 roughly of amino acids, and that makes this a transmembrane domain. So let's move on to the next one. I already told you that this is the x-axis, what this y-axis is. I really emphasize the fact that this is hydrophobic. I want you guys to know that you don't count every single peak just because it's above 0. You have to make sure it's about 20 to 25 amino acids long. Now, I want to make sure that you understand that there can be multiple peaks. So this is just a review on the left about everything that I explained to you verbally. You can read that on your own time. Now here, ignore what's on the left, but I want you to look at this plot right here. And without knowing the answer already, consider counting yourself how many transmembrane sequences you can find. And for this particular glucose transporter, there's 12. So there's 12 transmembrane domains. And the way that you depict that is that these sequences right here, the 12 are going to be, again, within the membrane. So they're transmembrane domains. So this first one is probably roughly like 10 to 30. So then you would write down here 10 to 30. That's position 10 of amino acid. This is position 30. So when Marcus is asking you label the amino acids, he's also basically telling you to label these transmembrane domains in other words. And when you consider what is an N terminus and a C terminus, go back to lecture 7 and 11 that differentiates single versus double transmembrane domains, and give it a try yourself. Look back at your previous problem set, look back at your exam, and see where you went wrong. And why is it that you put the answer that you put, and see what you can do differently next time if you were to see this again. All right, good luck, you guys.